In the previous video, we had talked about uniformly accelerated motion and free falling bodies. In this video, we will talk about a very important concept, that is the concept of relative velocity. Now, most of the objects in this world are continuously in relative motion. The term velocity is not an absolute term. It is relative in nature. It is always measured with reference to some fixed object. For example, velocity of a body on the surface of Earth is measured with reference to a point on the surface of the Earth. Here, Earth is assumed to be at rest. However, there are certain situations in which it becomes necessary to measure the velocity of one body with respect to another body when both the bodies are moving with respect to the Earth. In such cases, the distance or direction or both may undergo a change. Each one of such bodies is said to have a velocity relative to another. Now, to understand the concept of relative velocity properly, we consider two objects A and B moving with uniform velocities VA and VB along two straight and parallel tracks. Now, let x naught A and x naught B be their distance from origin at time t is equals to 0, and xa and xb be their distance from origin at any time t. Now, for object A, xa is equals to x naught A plus VA t, and for object B, xb is equals to x naught B plus VB t. Now, these relations for xa and xb are same as we discussed in uniformly accelerated motion. Now, consider this equation as 1 and this as 2. Now, subtracting equation 1 from equation 2, we get xb minus xa is equals to x naught b minus x naught a plus vb minus va t. Now, we label this equation as equation number 3. From this equation 3, we see that object B seems to have a velocity Vb minus Va with respect to object A. Thus, Vb minus Va is the velocity of object B relative to object A. So, VBA is equals to VB minus VA. Now, similarly, we can write the velocity of object A with respect to object B. That is, VAB is equals to VA minus VB. Now, if VB is equals to VA, then from equation 3 we have XB minus XA is equals to X naught B minus X naught A. That is, two objects A and B stays apart at a constant distance. Now, if VA is greater than VB, then VB minus VA would be negative. So, for negative VB minus VA, so the distance between two objects will go on decreasing by an amount VA minus VB after each unit of time, and after some time they will meet, and then object A will overtake object B. Now if both VB and VA have opposite signs, then magnitude of VBA or VAB would be greater than the magnitude of velocity of A or that of B, and object seems to move very fast.